Why is 0 factorial 1? Okay, because it does seem to defy the idea of you multiply down until you get down to whatever 1, right, and then you stop, right? Now, I'm going to argue for this the same way I would argue a very sort of reverse that. No, not that. I would argue this. How do you argue that? Because you all take it to be true, right? But it's the same problem. When you say, oh, a squared, but we define powers as you multiply this number by itself that number of times. And that makes sense to you. But the definition breaks down, the year 7 definition breaks down when you go to cases like this. So how do you argue it? Or do you just accept it and don't think about it? All right, people, let's play a game, okay?
Mafia.
Not mafia. Let's do it with a number, shall we? Okay, let's go to the power of 1. 2. 2 squared. 4. 2 cubed. Okay, and you can start to see what's going on, right? We don't need to... People who've spent time on their phones recently know these numbers very well. Now you're used to doing it forward, aren't you? You do it forward and the numbers get bigger, okay? But just as equally, you can go backwards and the numbers get smaller, do they not? As your power decreases, you divide by 2. And then you divide by 2, and you divide by 2, and when you get to here, we have no reason to think that the pattern changes, right? So this pattern becomes this, and so we divide by 2, and you get this, and you keep on going, and it keeps making sense, okay? Now therefore, can you argue for me why 0 factorial is 1? Tell me what 1 factorial is. 1. 2 factorial. 2. 3 factorial. 4 factorial. Okay, so this time, how do I go backwards? I divided by 4. Then I divided by 3. Then I divided by 2. Now, by the way, can I just say, the reason why I made a big deal about this is because, see, this is what makes maths, it's what makes maths interesting to me. You see, maths is, it's an imagined world. That's the point of it, right? Like, I know maths can be used to do stuff, and that's nice, okay? But the point is that, I'll come back to that in a second. The point is that it doesn't matter if it can be used for something or not. The point is that it has a consistent system of rules that's meaningful, okay? Now here's the amazing thing, right? There was a guy, a French guy, and his name was Fourier, okay? And he was the guy who he discovered this, right? Have a look at this for a second. What is this? You have language for this. This is a wave function. Now you don't know what wave function is, neither do I just drew it, okay? But the amazing thing about this, and this is what Fourier proved, okay, is that this wave function can be made up of, can be composed of, just take a whole bunch of sine functions, right? The whole variety of them. Some of them will be big, right? Some of them will be small, so you have to change, let's see, you have to change this coefficient out the front, and you change the frequency, okay? And if you add enough of them together, right, D, okay, and so on, you can make anything. You can even make weird looking things like this. You're like, I can make a function like that. It's a wave function. I know it doesn't look like it, right? It's got straight lines in it. What's with that, okay? if you add up enough wave functions, different ones, like this, okay, like this rather, you can get to something else. Now, here's the interesting thing. What was Fourier after? He just thought this was kind of cool. He was like, this is interesting, right? I wonder if you can do that. And he gave it a go, and out it came, okay? He was not at all thinking about practical applications, right? He was not thinking about, you know, a world of electric communications which uses this routinely in order to, you know, how does this thing know to convert weird stuff which is in the air into sounds? Sounds, right? How does it do that? Answer, using these. But Fourier wasn't thinking of those. He was just like, cool, let's just see what happens, right? And the application came later. Almost every field of maths, you know, complex numbers, you're like, why are we doing that for? They come up all the time for engineers, but that's not what the people who were thinking about them were thinking. They're just like, it's cool. 0 factorial equals 1. It does make sense, just like sum to the power of 0 is 1.